All right, I think we're gonna get started. Good morning, Philly ETE, how y'all doing? I'm very tired and undercaffeinated, but I'm extremely excited, despite my tired exterior, I'm extremely excited to be with y'all here today. My name is Huyen I'm an Android developer on the Android team at Trello. I've been doing Android, I've lost count, I think 6 or 7 years, somewhere in there. And I'm here to talk about a subject that I'm really excited about. It's one of my favorite topics, and that's layouts in Android. So quick show of hands, is everybody in the room an Android developer? Mostly? Okay, cool. So I really find layouts really fascinating. You know, we're kind of living in this world where we have all these apps that are really expressive and beautiful and innovative and, changing, the way we do things for the better, hopefully not for the worse. And everything kind of starts with this, right? These innovative interfaces that we build are all starting with XML files, right? And that's the core of kind of layouts. And what I also find interesting is that, in the Android community, we talk about performance a lot. You might have heard of Perf Matters, which is kind of a Google initiative to kind of execute people on different performance issues when working on mobile. And I feel like a lot of times when I hear people talk about performance, they're generally talking about Java code, compiler optimizations and this structure versus that structure and things like that. But what I want to talk to you about today is how layouts can affect the performance of your mobile app and kind of affect the experience of your users and affect your experience as developers. And it's kind of funny because I didn't think about this when I first started Android development as well. It's how can layouts affect performance? But it seems kind of obvious, right? Because ultimately, the layout, the interface is how we interface with the user, and they will feel effects of performance most directly through kind of that that venue, that connection through the UI and ultimately through the layout. So I want to talk to you about a few things today. Number one, what the heck do I mean by lean layouts, and why do they matter? And I want to connect kind of building layouts with the performance considerations and performance problems that you might encounter when you're building your beautiful, expressive, innovative interfaces in Android. And I'm trying, we're engineers, right? We want to problem solve. So I want to focus on finding problems and then fixing problems, and then kind of tie everything together with good practices. So my thing is I never say best practices, because what is best for you and your application and your application's UI depends very much on that application, on that UI, on whatever design you're trying to do, on your team, on the phases of the moon. So I just kind of want to give you a few kind of my rules of thumbs and things that I like to do when I'm kind of going lean with my layouts. So I want to start off with kind of maybe taking a few steps back and talking about the layout process in Android. So, everything starts with that XML file, that kind of declaration of the components of your interface as XML tags. But somehow that text, that XML has to get drawn up on the screen as these beautiful experiences. So how does that happen? So your XML layout is first inflated. So each of those tags gets instantiated into some view class, text view, image view. And as they're inflated, this hierarchy builds, right? So some views are children of other views, and views contain other views, and things like that. So as the inflation process happens, those classes, those views are instantiated, and they're connected to each other in this hierarchical fashion. Now, once your, XML file comes to life, it's not quite ready to go to the screen yet. There's several steps that have to be done, and there's several things that have to be done to that view hierarchy before it actually gets drawn to the screen. So there are 3 things. That view hierarchy has to go through measure, layout, and draw. So these are 3 phases that kind of get those views ready to be drawn. And these phases basically all consist of depth first, traversal. I always have trouble with that. And basically what happens is each of these phases starts at the root of your view hierarchy and does something to each of the views, kind of going from parent to child and all the way down, going through the entire tree. So in measure, what happens is the whole point of this kind of part of the phase is for each parent to measure each child and to figure out how big it wants to be. So each view in your hierarchy has some kind of intrinsic width and height, right? Some kind of notion of what the content size should be. And so what each parent does is says, each parent kind of figures out or asks each child, hey, figure out how big you want to be and let me know. So the child will calculate its measured width and height, that kind of intrinsic content width and height, and stores it in itself, and the parent will later kind of grab it when it's doing some other calculations. Now, since views are usually hierarchies and children can have children, often calculating content width requires going down and asking the children's children and the children's children's children all the way down, and then it's a recursive process very often depending on the structure of your view hierarchy. So after all of the views have kind of gone through and figured out how big they want to be, the next phase after that is layout. So what happens in layout is basically the final size and position of each view is determined. And so each, again, starting from the root and going from parent to child, each parent will determine the actual kind of screen size and position of each of its children. And then finally, after all that is done, then we get to actually draw the views in our hierarchy. And again, depth first traversal, starting at the root and going down. Each kind of view draws itself, and if it's a parent, it will then ask each child to draw themselves. So basically what happens is, you kind of go like starting at the parent draws on the bottom, and then the children get kind of drawn and layered on top. So that's kind of like the process. That's like that layout process that kind of lives behind, that kind of like takes our XML and does some magic spell and throws them up on the screen to create our beautiful interfaces. And you could probably write 100, 1,000 apps where this process goes along just fine. You don't notice any problems. Your app is gorgeous and beautiful and gets 5 stars completely in the App Store. But sometimes it's not the case. Sometimes you might have problems. Sometimes your UI might have performance problems. Sometimes it might be stuttery or jittery or animations don't seem to work quite right. Why does that happen? Well, a lot of that is just some problems that are just little traps or maybe things that are inherent to the layout process that can happen. So kind of as kind of like I've been going through my Android journey, I've run into these problems, and I've kind of found that what works best for me, and whenever I've run into problems with performance and layouts and performance in my UI, a lot of those problems can be solved by creating lean layouts. And what I mean by that is just making them efficient and trying to basically implement your cool designs and interfaces in kind of like the most efficient, with the fewest views, with the kind of like the easiest path possible, which is not always that easy, but yeah, so my whole point here, my whole concept here, lean layouts, why do they matter? Well, they matter because performance matters. And so what is performance? Well, performance really is like how efficiently your application uses resources. So when we think about performance, we're thinking about something that uses as little resources as possible, right? And so these resources could be, memory allocation, could be CPU, could be battery and network and data uses and all that kind of thing. And the thing is that the number of resources used by a layout is directly proportional to its complexity. So how do we kind of measure the complexity of a layout? Well, I usually think of it kind of along 2 ways. Number one, just the number of views in a layout. So it kind of makes sense, right? If you imagine like a XML layout and you have a ton of views in it, say you just have like 100 child views. That's a pretty complex layout. Even just looking at it, you can see there's a lot going on. And you can kind of easily imagine why that would be kind of resource intensive. Like the more views you have, the more memory you have to allocate to create these views, and probably it takes more time to actually go through that measure, layout, draw process to get all those views up on the screen. And in a very kind of similar way, but slightly different, the complexity of a layout can be also thought of as the depth of the hierarchy. So how much nesting are you doing? And so basically with layouts, and this is the really tricky thing, is that the depth of the hierarchy has a lot of impact on that process. Because you notice a lot of what I talked about with that layout process has to do with traversing that tree and parents to children, and things depend on each other. The parent is depending on the children do their thing so that it can do its thing. So there's a lot of dependency here. And so as you increase the depth of that hierarchy, you're increasing that dependency and increasing that complexity. And that can result in, again, more resources being used and possibly kind of worse performance. But really, when we talk about things like number of views and and the depth of the hierarchy, really what it ends up being overall is just how many times you do that measure and layout. How many times do you execute these two methods that kind of are kind of the home of where all this logic lives, on measure, on layout. And really, that's, at the end of the day, if you kind of look down to it, the complexity of your layout can be thought of as just in how many times you have to do these two things. And if you have bad performance, really, at the end, what happens is, you get jank. Your animations can stutter, your UI is less responsive than you'd like it to be, and you get a bad user experience. But so lean layouts can help you with your user experience and to make it better, but it can also help your experience as a developer as well. And a lot of that has to do with maintainability. So maintainability, I usually like to think of it as my resources as a developer, right? My time, my patience, my sanity. The more complex your layouts are, the harder they are to maintain and to refactor, and sometimes even to parse. And so that's using your resources and how many hairs you pull out of your head this week because you're just really frustrated with this thing. So a lot of times when you're creating layouts that are more efficient and that are leaner, it actually makes it easier for you as a developer. So it makes it more readable. So if you can do a layout in 10 views instead of 100, well, that's obviously going to be easier to read because the file is going to be smaller. And a lot of the layouts that we use, like say relative layout, right? So everybody here's probably used relative layout if you've done Android development. And the cool thing about relative layout is that it allows you to build these UIs as relationships to each other, right? You can position and size them relative to each other. Now, if you imagine a relative layout that's really complex and say that you have this view depending on that view and this view depending on this view, that can be just really hard to read if you just have a lot going on in that layout, right? If you have connections everywhere, it's not always apparent by just looking at the file where things are. So again, it takes you just more time to understand and to parse and to kind of, grok what's going on in your layout. And another thing is nesting, right? So I talked about the depth of the view hierarchy, just kind of a high level, dependency and calculating things. But I mean, just if you think about Android Studio, if you nest, every time you create a layer, a level in your view hierarchy, you indent the code. And then if you keep creating levels in your view hierarchy, that code gets indented until it's halfway off the screen or all the way off the screen. So again, even just a simple thing is making your views less deep will make your file easier to read. And even just going kind of past the idea that lean layouts are convenient for you as a developer just because you can read them better, they're also more stable. So again, going back to this idea of a relative layout, say that you have a relative layout and you have all these really cool ideas and you want to implement something really interesting and neat and things are depending on other things and just you have all these cool relationships. Imagine if you just change something, and then I've definitely had layouts myself where I've kind of done this cool layout. I've done some really interesting things with the relationships, and I get a design change, and so okay, well I'll just change the margin on this, or I'll change the relationship here, and then all of a sudden something on the other side of the activity just pops, or either out of place or out of sight, and just well, where did that go? And so the problem is that as your layouts get more complex, as you build extremely complicated relationships in this fashion, it actually makes it a little less stable. It's harder for you to refactor something without kind of messing up other parts of the screen. So the more efficient you are, the less I guess it's almost like even having spaghetti code but in your layout. The more you can stay away from that, the more stable your layouts will be. And again, it will be a better experience for you, the developer, and ultimately better for your user as well. So there are very specific places where problems can kind of pop up specific to layout. So I kind of been harping on this a lot so far about deep hierarchies. And again, it's because of the tight relationship between parents and children and the way that measure and layout work that the parents and children have to communicate and kind of coordinate in a sense, their size and position, that the deeper you make your hierarchies, the more this complexity, the more this dependency increases, which can have kind of some pretty interesting effects. And it's just, it's harder to, I guess, process that layout. Another place where changes or where problems can really pop up is when change happens. So if you can see this little snippet of a layout that I have. So say that the pink view changes size and position. Well, since it changes size and position, it has to be remeasured and relayed out, right? No big deal, cool. But say it has a parent, and the size and position of that parent is very likely to depend on the size and position of that child. So not only will that pink view have to get remeasured and relayed out, but also its parent will as well. All right, well, okay, so the parent will remeasure and relay itself out, but that might also change the size and position of its sibling. And not just that, but if the parent has a parent, then that parent will also have to be remeasured and laid out. And so what happens is this kind of cascade effect, where a change kind of deeper in the tree results in this whole cascade of kind of like invalidating the current measurements, and then everything having to be relayed out again. And so this can kind of, you can kind of see where we get into trouble here a little bit if this happens a lot. But the thing is, we can't stay away from change in our view hierarchies, because we're all about material design now, and we're all about motion design and creating delightful, highly interactive, applications. And animation is change, so we can't just stay away from it. We can't just avoid this kind of situation. We have to kind of deal with it. And again, you could write 100 apps where you're animating everything in the app and everything is fine. But every now and again, problems pop up, and this is kind of like a very likely place it will pop up. So another place you might have problems is with the platform layouts themselves. So going back to relative layout, which I kind of like to pick on because it's an easy target. I talked about the kind of process by which layouts are rendered to the screen. So I talked about measure, layout, and draw. So some of the platform layouts actually sometimes need more than one go at measure and layout to kind of complete this rendering process. So relative layout. So relative layout is awesome because of that ability to kind of like just establish these relative relationships. But because of that complexity and because you have kind of these interdependencies, relative layout actually needs 2 passes just off the bat with measure and layout to actually resolve kind of all these different relationships and finally position everything on the screen. And you might think, well, that's not too bad, right? Just 1 extra measure and layout pass, that's okay. But it's not just like 1 extra, right? So if you imagine a relative layout living in a relative layout, that parent relative layout will get measured and laid out twice, but the child relative layout will get laid out 4 times, measured and laid out 4 times. So it's like a multiplicative thing, it's not additive. So, and again, you might not have problems with it like most days, but if you might have one day one small problem with the relative layout. And if you have very nested layouts, if you have this kind of like multiplicative thing going on, things might snowball and snowball and snowball until one day you wake up and your app's unusable for some reason you're not quite sure. And the last one I want to talk about today is lists. So lists are like everywhere. I can't think of too many like Google apps that don't have some form of list or another. And what are lists but really a layout that takes a smaller layout and just copies it a ton of times, right? And so it's kind of easy to see, well, if you have a simple list item, no big deal. But if you have a list item where you're trying to like maybe display like some dense data, or you're just trying to do kind of maybe some fancy animation on a single list item, you can see that as we start to copy this list item over and over again, we might again run into the same problems that we had before, just kind of magnified by the number of items you have in the list. And so these are kind of like the big, I guess, culprits a lot of times when you're having performance problems in your layouts. And another interesting thing though is that often when you run into a problem in one of these areas, you tend not to run into these problem areas in isolation. Usually they kind of grow in packs, and you have like a list and you're animating it. So you have both of those things to contend with. Or you even have like a relative layout that you're trying to animate that kind of the problems start to compound. So that's why I think it's important, and why this concept of I feel like doing efficient layouts and kind of being aware of them is super important, because things will like kind of snowball, and things will just kind of come at you in many different ways, and there's just so many different facets to like performance problems that you kind of have to be just aware of everything and try to like tackle it from like a very fundamental like way. Okay, so that's my appeal to you on why lean layouts are important. Now, if you have performance problems, what can you do about it? Well, first you need to find them, and there's a lot of really great tools that we can use to find problems in our Android layouts. So the first one I want to talk about is Hierarchy Viewer. So Hierarchy Viewer is this tool. It's an SDK tool. It used to be like command line only, but now it's like in the Android device monitor. And it's this really great visualization of your view hierarchy. And just like a general tip, if you want to use it, it's best to use a physical device. And nowadays they just tell you to find a device that has 4.1 or above. It used to be that you could run it on devices lower, but then you had to run like a separate view server, blah, blah, blah. But yeah, if you use it, use a physical device running 4.1 and above. So to kind of demonstrate how you might use Hierarchy Viewer, I have like a sample app. And so what I did in my sample app was I created like a cute little layout. Video's playing. So I have a lot of images. They're all of food because I'm always hungry when I'm like doing slides. And as you can kind of see as I'm scrolling, there's a little bit of jank and a little bit of like stutter in the scrolling. Now some of that, to be fair, is because I have a lot of images. But part of that is also because I did the most efficient, disgusting, like stupid layout that I could. You're very welcome. Because I wanted to show you, like how you can detect like maybe some problems with Hierarchy Viewer. So to use it, you open up the Android device. The Android device monitor. I think I got that right. And so basically, if you look at the screen, there's going to be two tabs up in the upper right corner. There's DDMS, and then there's Hierarchy View. If you don't see it, there's probably like a plus. There's like a little icon where you can kind of like look for that tab. So what you do is you go to the Hierarchy Viewer. Is the video playing? Is it playing? Yeah, it is. So you're going to click on Hierarchy Viewer. And what happens is you're going to get this window tab. Now the window shows kind of like active windows in your kind of active windows that you've recently gone to, and it's hard to see, but it's listing actually like my launcher activity and my Hierarchy Viewer activity. So what you want to do is when you want to kind of analyze the structure of a particular activity's hierarchy, just click on the activity that you see in your Windows list. And then if you open up all of the Hierarchy View windows back up, you'll see that you'll have like just three different kind of like overviews of your hierarchy. So there's kind of like a tree view. It's like a horizontal tree that always messes me up. There's a layout view, which is kind of like basically the outlines of all the components in your layout. And then there's kind of like this detail view of the tree. And you can basically kind of go, kind of like ping back and forth between those three views and actually kind of look through your hierarchy. And it gives you a really good like 10,000-foot view of what's going on. So if you look at your tree and you see that it's really, really deep, like it's taking up a lot of horizontal space, you can kind of think, okay, well, my hierarchy is really deep. Or if you happen to see just like a bunch of like gray boxes in one area, you can say to yourself, oh, well, there's a lot of views here. So some really neat things about this is that when you click on a node in the tree, it will actually show you the portion of your UI that is controlled by that node. So you can actually see kind of like, it really helps you kind of visualize like what exact pieces of your UI might be having problems. And you can kind of click through and navigate. It's a really kind of handy tool. So there is this thing that it does, and I'm sorry, I apologize, it's a little hard to see, but in the Hierarchy Viewer, it actually will try to give you numbers and try to give you measurements on how long measure, layout, and draw take. And you can kind of see like these three little dots. They're meant to kind of be like this qualitative, like good, not so good, and bad evaluation of how long these three phases take. Don't use them. I gave this talk at a conference, and Chet Haas from the Android team was there, and he came up to me later and said, don't use them. They're inaccurate, and there's like reasons for that. It's like it's basically how like your activities get rasterized and then analyzed by the tool. That it's inaccurate, and like things about the CPU and GPU that I wish I understood better and would love to talk about but can't. But basically, the Hierarchy Viewer, even though you can't use the numbers, is just a really great way of kind of like getting a really high-level view of what's going on. So you should definitely still use it for that. There are some other tools, though, and one of them is actually something that is kind of poised to replace Hierarchy Viewer, and that's the Layout Inspector. Layout Inspector, I think, has been out for, I want to say, like a couple years almost by now. And again, it's kind of this tool to help you visualize and navigate through and basically debug layouts. But you can kind of use it as a way of evaluating how kind of complex and how deeply nested or how kind of like tightly packed your views are. So this lives actually in the Android Monitor, which is kind of a tab right inside of Android Studio, so you don't even have to launch the device monitor. And it's got a few different components. So if we go ahead, so what you do is like once you, in Android Studio, if you have like a device connected through ADB, what you can do is you open up the Android Monitor, and there's actually a little button. It's hard to see. There's a little button with like 3 circles in it. That's the Layout Inspector. So you click on it, and similar to Hierarchy View, you get this kind of like drop down where you can select kind of like the previous windows, previously active windows, and you can kind of click on an activity that you're interested in. And what it's doing is basically taking a snapshot of that activity, of that window, and like analyzing it and analyzing the structure. So on the left, you get this kind of list view that is your hierarchy, and then in the middle, you get this kind of, it's like a hybrid of that layout view that was in Hierarchy Viewer, but also kind of an actual rendering of your activity. And then you can kind of do the same thing. You can kind of click around and like navigate and kind of see what is where. And again, like you can kind of just make some very like high-level evaluations of your layout. So if the list is very, very long, your hierarchy is probably pretty deep. And if there just happens to be a lot of stuff in that list, again, you probably have a lot of views somewhere. And it's just kind of a way of like getting hints at where problems are. Sometimes it's hard to pinpoint problems, but using kind of these tools and kind of getting ideas of where problems might be will give you a nice head start. And kind of again along this line, like there's a new-ish view in the layout editor called Blueprint View, and it's more of a structural view. It's kind of like a skeletal view of your layout. And again, just kind of looking at it and saying, hey, like I've got a lot of things overlapping here. Maybe that means like I've got too much nesting, or like there's a lot of stuff going on. Like again, just high-level evaluations. So another tool that's great to use is systrace. So systrace is this tool where you can actually track system and application process execution. And what happens is you kind of run a trace on your app for so many seconds, and it will generate this kind of interactive HTML report. And you can actually kind of see how different like processes and different things are executing in that time frame that you traced. So this is really handy for kind of really evaluating kind of frame rendering time. So generally when we think of smooth UI, we think of something running at 60 frames per second, which basically means that each frame, so each like frame, each kind of like rendering of your UI to the screen needs to take place in 16.6 milliseconds. And if it kind of takes longer than this, that's when your UI gets janky, right? That's when it kind of feels slow. That's when frames might be dropped. That's when things start to kind of go a little haywire. So systrace is kind of good if you really are trying to drill down to this kind of like information and trying to see like where your app is at in terms of like FPS and just like the smoothness of the frame rendering. So what's really cool, and I apologize, it might be a little hard to see in the back, but there's these little circles, and each circle has an F in it, and those are actually marking each frame rendering. And it's kind of colored green, yellow, red to again tell you, oh, hey, this frame rendered under 16.6, a little over or a lot over. And the nice thing about systrace is that when you click on these different kind of like processes and like things that are being run, you can get a little bit of information about what's going on. And in fact, it'll actually give you alerts. So there's like a bar at the top, and it'll actually kind of put these little markers on different kind of areas where something bad happened. And so if you have a frame that took a long time, like say, so for example, it might be hard to see, but there's actually an alert for expensive measure layout paths, which is basically like the big thing that I'm trying to like, kind of point fingers at and yell at today. And you actually will be able to see that in systrace. So again, a really good tool for kind of looking very specifically at these kind of problems. If you're like really into crunching numbers, you can use dumpsys. So dumpsys is a tool that you can use in the command line, which dumps quote, interesting information, that's what the documentation says, on system service, the status of different system services. So there's actually a parameter that you can pass to it, GFX info, graphics info, and you can actually get detailed information about how the different like frames are executing. And actually, I think in Marshmallow they added yet another kind of like parameter to this, and it's frame stats. So you do graphics info and also frame stats, and that gives you extremely detailed frame timing info. So it'll actually tell you like the nanoseconds and give you this timeline of like how like long the measure layout draw took and how long the draw phase took. So really, really detailed info if you're really looking to kind of get down to the nitty-gritty and actual timing of things that are happening in your app. But that's a command line tool. There's actually an API tool that does the exact same thing as that dumpsys with the frame stats, but it's a kind of a pub sub API that you can actually attach to the window that your activity is currently running in, and it gives you the exact same information. It's like these like nanosecond timings of when things happen, but in a nice API that you can actually consume in Java code and log and print out in a much easier way. And it's exactly like frame stats, but it's actually better because when you run frame stats, you're limited to like the last 120 frames of history, I think. Whereas if you do frame metrics, this frame metrics listener thing, it's not limited in that fashion. So again, a really nice kind of new, you have to be on NuGet. You have to be on 24 and up, I think, to actually use it. But again, it's a really great way of doing like numerical analysis on timings and things like that. All right, so we talked about finding problems. Let's talk about fixing problems. So when fixing problems, especially with layout performance, it's always great to start easy. Start with the simplest things. And the simplest thing you can do is to make lint happy. And I love lint and I hate lint, kind of depending on the day and how much coffee I've had. But when it comes to like layout performance, the things that lint complains about are pretty much like your #1 priority to kind of fix. And they're also generally tend to be straightforward things that you really, really shouldn't be doing. So I made another gorgeous like layout for you with like some horrendous pink thing going on at the bottom, just to show you kind of like some interesting things that lint might complain about. So something that you should absolutely fix that if lint tells you that it's happening is to remove useless parents, and that sounds like a really judgy statement, but it's really quite true. So what is a useless parent? So like kind of like in this example, might be a little hard to see, is that, so say I have a relative layout. I have another relative layout in that one, and the inner relative layout has only one child. That inner relative layout, if it doesn't have any kind of like styling or like padding or anything like of this nature, it's a useless parent, and you should get rid of it, because all it's doing is just creating an extra layer in your an extra level in your view hierarchy, and just making things just a little bit more complex and a little bit more complicated. You should remove it. Another thing that lint will kind of warn you about that you should absolutely fix are nested weights in linear layouts. So linear layout used to be like my favorite layout, and one of my favorite features was using weights, so that you could specify these constants and do this kind of cool programmatic like distribution of space between like the different members of that linear layout. And that's really awesome. And I'm sure I've done in the past where I've actually decided that I really wanted to like have one linear layout with weights and then have another linear layout inside of that with also with weights. But that's really bad. And lint will say, hey, you shouldn't do this, they're bad for performance. And if you think about it, it's not too hard to see why. When you're using weights, you're introducing a variable, you're introducing an unknown into kind of like the layout process for the linear layout. And so it has to resolve that kind of unknown. And so what happens is if you start nesting these kind of weights, you're kind of compounding the kind of unknown factors. So basically the linear layout has to do more work to resolve all these different unknowns. So it's bad, don't do it. And honestly, in my opinion, there's always a better way to do it. Like I feel like I've like argued with people on this, but if you're nesting weights, I can almost guarantee there's like a better way to do it, a non-weighty, less lint, yelly kind of way of doing your layout. And that's kind of like the fun thing about doing layouts, I think, is that there are so many ways to do things. It's always kind of a fun challenge, and you shouldn't try to limit yourself to things that lint yells at you for. So another thing that lint will yell at you for is too much nesting. So there's actually an environment variable in Android Studio, I think, that's like called max view depth or something. But basically, if you're an absolutely ridiculous person like I was when I made this layout, and you start nesting and nesting and nesting and nesting and nesting, eventually lint will yell at you. And this is kind of what I was talking about before, when you nest so much that it's off the screen, you have to scroll. Don't do that. But before you get to that ridiculous point, lint will probably throw a nice yellow warning at you, and it will say, hey, you're nesting too much. And honestly, if you're nesting this many levels, you're probably doing something wrong. I'm sorry. So again, something that's really straightforward. It might not be easy to fix if you've already gone a little bit crazy with 20 levels of nesting, but it is something that will be very impactful to your performance, and is something that is kind of like a prime candidate for you to refactor and to fix. All right, say that you've made lint happy, but your app is still not happy. It's not quite performing still. So the next kind of like my personal next step is to simplify and reduce. And so basically, the goal here is to basically simplify layouts and reduce the number of both kind of individual views and kind of layouts and nesting that you're doing. So there's a lot of different ways you can do this. And sometimes you can just rely on features or attributes of views that you're already using to kind of pick up the slack where you would normally kind of throw in some extra views. So at the top of this activity here, I have something that we see all the time in Android. It's an image view, like an icon, next to some text. And I'm sure when I first started Android, I probably just did this 100 times where, okay, image view, text view, horizontal linear layout, awesome, I'm gonna go to lunch. And that's totally fine. Technically, that works, right? That's how I did this first kind of icon wibbly wobbly text thing. And it works. But lint actually will yell at you for this, that you don't have to do it this way. And there's actually a much more efficient way of doing it, and that's with what are called compound drawables. So basically, text view has this really great feature where you can give it a drawable, and you can assign it you can tell it oh, put this drawable to the left, or this drawable to the right of the text, or the top and bottom. And the text view will actually do the work of rendering that drawable in line with your text, and you can even kind of add padding and stuff like that too. So it's a really great way, again, of taking something like this, which we'll, I guess, call the naive kind of implementation, where we have 3 views, right? The linear layout, the image view, and the text view, and 2 levels in our hierarchy, and reduce it all the way down to 1 text view. So we saved ourselves kind of quite a bit in our hierarchy, and at the same time, we've kind of like, in a sense, compacted that kind of visual element, right? So everything is a little bit more concise. You know, we have the text view and the closely associated drawable that goes with it, which is really cool. And I mean, compound drawables are really great. You can actually do some pretty interesting things with them, and you can kind of take it to a ridiculous level. So if you can see like my middle example, I have some text, and I have an image to the top left, right, and bottom. And so the first example is like that non-subjective one. It's actually done with a text view and 4 image views, and then wrapping that all in a frame layout or something. So that's what is that, like 6 views, right? The bottom one, the nonlinear guy, I was able to do that with just a text view, 1 single text view, 4 images, and 1 piece of text. So you can kind of see, like, just picking the right features and just picking the right attributes, you can really reduce and simplify your layouts and kind of do some really interesting things. Okay, so say I have a layout like this. So I have a conversation between 2 people that I'm trying to render on screen for some reason. And I have like 2 different styles. Say like I have person A talking in style, like the white text style, and I have person B talking in the yellow text style. So I know like when I was first starting Android, I did this a lot. I would like, when I would see pieces of text that were like different styles, I would just throw them in different text views and apply the style, right? It seems very straightforward. But you don't have to do this. So there's this really cool set of classes. This really cool like kind of family of classes called spannables, and basically they're very similar, I think, to like HTML. You know, like it's still kind of going back to like HTML spans, right? Where you kind of like take a section of something and you apply a style to it, and you can do that with like character sequences in Android Studio. You can take a character sequence. You can say, okay, from this index to that index, I want it to be like blue, and from this index to that index, I want it left aligned, and things like that. And it allows you to take a single string or a single character sequence and apply just all kinds of styling to it, like custom font faces, all that kind of stuff. And ultimately, while this is kind of powerful in and of its own, it's really cool for just like styling and doing really advanced kind of like stuff in terms of typography. It also results in like super efficient layouts. So if you kind of can see the code, basically instead of having like 3 text views to implement that conversation, I can take my 3 styles and apply them to like the different, you know, kind of the appropriate indices in my character sequence. And at that last line, I just call set text on a single text view, pass in this kind of spannable string that has all these different like crazy styles set at different places. And what I do is I take this linear layout that had 3 text views and 2 different styles, and take it down to a single text view. With some spannable work on kind of like in the background. And that's kind of a disadvantage of doing spannables, is like I personally like when a lot of my UI and styling is just in the XML, because I feel like it's like a good kind of like a single stop shop for all of your UI stuff. But you know, sometimes depending on whether you don't have the support for the kind of styling you need, or you want to do something like this where you want to make your layouts more efficient, spannables could be a good solution for you. Just another caveat too is that if you're localizing your app a lot, you have to be careful with spannables because, of course, because the styling is based on indices and like localization, the indices will change based on what the actual string is. That's another disadvantage. But you know, if you find yourself in a position maybe where you have some dynamic text, or you're really trying to do some cool things, and you also want to make your layouts more efficient, you should definitely check out spannables. And so just going back to my example, the top section is done kind of in the naive way with 3 text views. The bottom is done with a spannable. So you can see there's no visual difference, or the final like product is the exact same. Okay, this is like a pet peeve of mine. I used to see this like on teams that I was on, and it would drive me crazy because I'm a little nitpicky like that. So I have like 3 icons, and they're in a layout, and I have like a simple color background. And I know like a lot of times like when we're building layouts, there's like this, I feel like there's a lot of like impulse to like make our layouts very modular and easier to read by like, say, grouping visual elements together with a frame layout, or maybe like, you know, you kind of imagine like padding and margins as something that's kind of like applying to like, you know, kind of like external to the content. And so like the inclination is like to maybe wrap things in frame layouts, or wrap them in another layout, just to kind of like separate parts of the styling and parts of the view. And that's okay, and that obviously works, but sometimes if your view gets really complex, it can be just extra stuff in your layout. It's just another extra parent that you can get rid of. And so really, like, if you kind of see something like this where you're just wrapping content just to add padding or background, don't be afraid to just set the padding and background on the view itself. And and try to. I know, like, and I have this inclination too, where I like, my code to be modular, and I like to try to make my UI modular as well. But there's other techniques to do that, and I think, especially when you have performance problems, eliminating any kind of like excess is a good thing. So never be afraid to set padding and background right on your content. And that's just a simple example of basically one is done with an extra frame layout and the bottom one is done without it. Same thing. It comes out the same. Okay, so say I had something like this, all right? So I have a purple text view, a blue text view, and an orange text view. And say I want to do something kind of like, well, I want the purple and the blue one vertically aligned, but I want the pair of those to be horizontally aligned with the orange one, okay? So I know I did this in the past where I was like, oh, okay, that's awesome. That's like 2 linear layouts. So I'll do a vertical one and a horizontal one. And there's probably someone in the back kind of yelling, why aren't you using a relative layout for that? Well, you can. And I think like a lot of like simplifying and reducing your layouts has a lot to do with just picking the right layout, right? And sometimes something like this might show up just because maybe you're on a team and like 3 of you are working on the same feature, and so one person does one part and that kind of seemed fine, but then another person came in and added something on top of that, and so you kind of end up with these kind of weird like nested things that you don't have to do. And so a quick solution is to use maybe something that is just more efficient or just kind of more conducive to like what you want, what you're trying to do, what you're trying to implement in the UI. So say you have something like constraint layout. Constraint layout is actually pretty awesome, and I'll talk about it in a second. So rather than doing those 2 linear layouts, I could just do constraint layout. And again, I go from like 5 views and 3 levels down to like 4 views and 2 levels. And again, just like small savings, like cutting things here and there, will kind of buy you a lot over the long run in terms of layout performance. So I just wanted to kind of give a shout out to constraint layout. Oops, real quick, my bad. There we go. So it's a new layout. It was introduced last year at Google I/O, and it's actually pretty cool. It gets compared to relative layout a lot, and I think that's fair, but you should really think of it more as like relative layout on steroids with a little bit of linear layout like thrown in there. And what's really interesting, and I think was what really cool in context of this talk, is that one of the main drivers of this creation of constraint layout is to give us as developers a layout that's super expressive, but also super performant. So constraint layout has, again, this kind of idea of building relationships between views and positioning and sizing things as relative to each other, but it has like way more functionality. It's a little bit actually lower level than relative layout, which allows you to do more things with it, right? Because you're not boxed into how relative layout does things. And it's cool because you can now do funky things with it, but at the same time, because you can do more with a single layout, that actually helps you become more performant. Because really, when we're talking about layout performance, it is all about flattening hierarchies and reducing views. And constraint layout is going to be cool because you can do all kinds of cool, neat stuff with it, but it also will just, in general, just make your layouts more efficient because you can just cram in so much. You can build these relationships with a single view. It allows you to be more performant. So I would definitely check it out. It's still a work in progress. There's a UI builder that is also a work in progress. And I wouldn't just go through your app and just tear things out and put constraint layout in. But if you're building a new UI or if you're trying to experiment, I would definitely look into it. There's just a lot of cool stuff about it. I wish I could talk to you about constraint layout a lot, but it's a really cool thing, and I think it's a really powerful tool as we go forward for, again, building efficient, expressive layouts. And so to go back to my example, the top one is done the naive way, the bottom was done with constraint layout. Again, got the same result, just with a little bit less cruft in my layout file. So I kind of think of this as like the nuclear crazy option, is that if you have done all these things that I previously mentioned, you're still having performance problems. One option is to go custom. And that is to basically write your own custom view or view group for whatever interface you're trying to implement. And it's hard. It's hair pulling. It's something that can keep you up at night, and I know I have because I tend to kind of go overboard sometimes with my custom views and view groups. But it's really powerful because you get to have total control over how that view is laid out and drawn, or measured and laid out and drawn ultimately. And that can allow you to do kind of really interesting things, like basically bypass all of the platform layout problems. You don't have to worry about the double measure and layout pass with relative layout. If you can position your own views because you know exactly where they're going to go. And I actually did this. This actually was a performance thing that first got me into custom views because I was on a gig, and I think it was like we were like sending, it was like an app where we wanted to send photos to like a printer. And so what they wanted was that for each photo, they wanted us to print out like every single size and every single like option that went along with each print. So basically each like list item had like a ton of text in it. And like when we first implemented it, we did it the really, really lazy way and just did a bunch of text views and like, you know, and also like the thumbnail for the photo. And then of course on top of that, we wanted to swipe to dismiss. So the first time, we got it all implemented and we did the swipe to dismiss, it was just like, it was like, it was not good. And I had no idea what to do at the time, and I think I just happened to like read something about doing custom view groups, and I just had this idea, well, maybe we just have too much going on. And so I actually re-implemented the whole thing with spannables and also with a custom view group because I could tell, I could calculate very precisely where all these different pieces would go. And I implemented a custom view group and it moved like butter and it was awesome. And then we refactored and got rid of that entire design the next week anyway. But it was a really good learning experience because it kind of taught me the power of custom view groups. And I would definitely recommend that if you're in it for the long haul with Android development, that you learn how to do custom views and view groups. It just teaches you so much about this whole crazy process of layout and view drawing. I would start simple. Start with things that are really straightforward. Again, like a view where you know precisely where this image should go and that text view should go, because you're kind of basically calculating all the X and Y's for each individual view. Start out with something like that, something that's really easy. That's something where the math is really easy. But don't spend too much time on this. It's a really powerful tool, but kind of like the flip side to like trying to make your layouts more performance is really kind of like return on investment. A lot of times, especially when you're doing something like with custom views and view groups where you're doing everything yourself, you don't get the benefit of like these kind of like, tested and like years old layouts that, you're pretty much, you can feel safe that will work, right? You're kind of exposing yourself to bugs and to like weird edge cases and things like that. And you might end up spending more time getting your custom view group to work rather, more time trying to do that than just going back and saying, hey, maybe we should redesign this, or maybe we should kind of maybe punt on this animation or something for now until we figure out a better solution. So I guess in general, though, with custom view groups, I would highly recommend you do them, but kind of be aware that you kind of have to balance the performance gains you get with it, that you get from it, with the effort you have to put into it. But again, try it. I'm a really big fan. So finally, I want to talk about some good practices. So number one, just anticipate and develop good habits. So really, I think getting good, if you can say I get that if I could say that I'm kind of good with layouts, is about kind of developing good habits, and a lot of that is just screwing up and learning. Doing something stupid, having your layout run crap, and then fixing it, and then you kind of build this repertoire in your head of situations where problems might arise and things kind of cool solutions that you found out. Okay, so in this app, I'm doing this list item, but I also have this particular kind of setup in it, and usually that ran pretty bad last time and I had to do the custom view group thing. What can I do this time? How can we maybe either tweak the design or maybe do kind of other things that will help alleviate the problem before we actually get to the point where things are running like butt. Using the simplest solutions where possible. And I think a lot of times, the one thing I like about layouts is that it's still a really cool engineering problem, right? It's we get a design, we get a spec, and it's our job within some constraints to implement it. And there's always a million ways to do it. And you like to challenge yourself to do cool things, use the new cool fancy toys. And that's great, but sometimes, especially with layouts, and especially because this is something that impacts your user experience, sometimes the simplest solutions are the best. And I would recommend, especially when you're on a long-term project or you're on a very complex, very deep app, to use the simplest solutions where possible. Again, it's kind of cutting out as much as you can at the beginning, and then so you can reap the wonderful performance benefits later, right? It's that whole an ounce of prevention is worth a pound of cure kind of thing. And if anything else, if there's one thing that you should remember from all this rambling I've been doing, is that your layouts need to have fewer views and they need to be flatter. And that is kind of the big thing to remember and the big key to like layout performance on Android. Fewer and flatter, less nesting in your hierarchies where you can, and reducing views down where you can. And don't use relative layout at the root. I just like mentioning this, and it's kind of a very specific thing that I hope we have to worry about less. But back a couple years ago, whenever you would start a new activity in Android Studio, it would put relative layout at the root of your, the XML file it generated. And I think Romain Guy and Chet Haas had a talk a couple years ago at the Android Dev Summit where like very specifically, don't use relative layout at the root. And then, of course, after I kind of repeated this information, I had a bunch of people saying, well, we have relative layout at the root, and it's fine. And again, like, yes, you could probably create an app with a relative layout at the root, and you'd be OK. The problem is, again, is that sometimes you run into situations with your particular app or just a particular screen where you're doing a lot, or just from the structure of it, you might run into problems. And with things like relative layout and just anything else that might be problem, like error, like bad performance prone, the closer it is to the root, the more those problems compound, right? So like the higher that relative layout is, the more chance it has to affect other things below it. So fewer and flatter, and try to keep problem areas like away from the top of the view hierarchy. And don't let problems accumulate, and that's just something like do spring cleaning. Like, we all have to ship code. And it's not really worth it to sit around for like forever and never ship code because you're trying to get the most perfect, efficient layout ever, and trying to use, all of these like simplest techniques and trying to figure out like, how do I get this view group working? You have to ship code. And sometimes that means that you'll kind of let something slip, and that's okay. But whenever you can, clean things out, reevaluate. If you're starting a new feature, try to like make that as fresh as possible if you had to kind of compromise before. Or if you're refactoring something, maybe reevaluate like the layout and see what new tools you have, and maybe like things that you can pull in that you weren't able to before. And finally, again, just to reiterate, balance performance gains with development effort. Performance is important. Shipping is also important. So you have to kind of balance those two things. And sometimes some solutions are appropriate and sometimes they're not. So it's all about just figuring out what works, messing up, and fixing it. And that's all I got for you. Thank you so much for listening to me today. Follow me on the internets. Thanks.
Anyone has any questions with a microphone?
So you can't use, or you shouldn't use relative layout at the root. Is constraint layout acceptable, or is that run into the same sort of issues?
So the question is, does constraint layout have the same issues at the root that relative layout has? So it actually is very specifically meant to be like your parent layout, and that's again because it's so powerful, you can do a lot more with it. So it is meant to be used at the root. And there's actually things about constraint layout that are a little bit different from relative layout. So that double pass thing that I mentioned, constraint layout for the most part doesn't have that problem. There is like kind of a match parent, fill parent thing going on with it that sometimes requires 2 layout passes, but in general, it's meant to be used in that fashion. It's meant to kind of give you be a good root. It's a good parent, I guess is what I'm saying. So.
Have you had any difficulty measuring the size of text? And also, what is lint? Which version of lint do you use?
So the first question was, have I ever had problems measuring text? Yes. That is one of my most hated problems in Android. It's not a good solution. I don't know. I know there's a lot of really cool text stuff up in O, so I don't know if that's going to change. But yes, I have had problems. A lot of it is kind of best guesstimate in my experience. So I guess we'll see what happens in the future. I haven't researched it too much, so I might be just making stuff up in my head. And I'm sorry, the second question was, I lost it.
Oh, lint. I know different versions of lint. What lint tool do you use for analyzing your errors on your Android code?
Oh, I'm just using whatever lint is integrated with Android Studio, to be honest with you. So I'm not quite sure what version that is.
So it's in Android Studio?
It's in Android Studio. It's integrated,
yeah.
Thank you. It's
yeah. If you have a Gradle build, you can also just do a Gradle W check.
Oh.
Yeah.
Thank you.
Yeah, thanks. Yeah? Okay. Anybody else? Okay, cool. Well, thank you all so much. You are free to go.